So coordinate plane, two number lines that intersect. What does intersect mean? Where they meet, where they cross. So two number lines that intersect. Where do the two number lines cross at? Intersect at this special place called 0, 0, the origin. And when those two number lines intersect at 0, 0, what happens? So like over here on the left, what do we get? Negatives, yes ma'am. And what do we get over here on the right? The positives. What about down here? Negatives, the negative y's, and up here the positive y's. Okay, so when these two number lines intersect, it divides the plane, a flat surface. You know, the plane is a flat surface. It divides it into 4 sections. The 4 sections are called quadrants. You know, quad 4, like a quad bike has 4 wheels. So, anyways, two number lines that intersect at 0, 0, dividing the plane into 4 sections. Okay, let's label them. So first, let's label this right here. Oh, wait, hold on. Let me get my purple pen. What is this called right here where they cross? What is that dot called? It's the origin. Okay, it is the origin. O-R-I-G-I-N. And that ordered pair, its special location, its GPS address is at 0, 0. Okey-doke. In a coordinate plane, we have 4 sections or 4 quadrants. Okay, what are the quadrants? 1, 2, 3, and 4. How do we have to write them? Do you remember? Roman numerals. And quadrant 1 is up here in the upper right-hand corner. We have to use Roman numerals. And I'm going to write this better. This is quadrant 2, so we're going counterclockwise. Quadrant 3, so we're going backwards counterclockwise. And quadrant 4, IV, Roman numeral 4. Okay, so let's keep labeling. So anybody know what this horizontal line is called? It's the x-axis. And notice on this graph, it doesn't say x-axis or y-axis. Sometimes, not all the time, the axis is labeled. So this is the x-axis. The x-axis is horizontal. If you can't remember horizontal and vertical, it's up there on the wall behind Mr. Gayhart. So horizontal is flat, vertical is up and down. Okay, and then this vertical line is the y-axis. It goes up and down. It is the up and down direction. All right, next. An ordered pair. What does it look like? All right, so an ordered pair starts with our x direction. and then our y direction. So it's like the alphabet. X comes before y in the alphabet. So our x direction, our x coordinate, tells me which way to go, left or right. And remember, left of 0 is negative, right of 0 is positive. Left of 0 is negative, right of 0 is positive. And then our y coordinate tells us if we go down, the number is negative, or up, which is positive. Now, all four of these directions, left, right, up, down, start at the origin. So if I start at the origin and I go left, I'm going to be a negative. If I start at the origin and I go down, it's going to be negative. If I start at the origin and go right, it's positive. Start at the origin and go up, it's positive. Ordered pairs always have parentheses. So if I type in 3, -4 in Desmos, nothing will happen because ordered pairs have to have parentheses around them. Okay? The parentheses mean that these two go together. The x is my first coordinate, the y is my second coordinate. They stay together. These are my GPS directions. So it tells me which way to go to get to that point on a coordinate plane. All right, let's name our ordered pairs. So a couple years ago, when I went from teaching 7th grade and 8th grade to teaching algebra, I thought everybody knew how to plot points and name points on a coordinate plane, but boy was I wrong. So if at any time you do not know how I got, 3, 3 or 7, -2, you need to ask Mr. Gayhart or I. Tomorrow you're going to do an activity where you're going to drag and drop points on a coordinate plane. And if you're getting them wrong, you need to ask, like if your picture doesn't look like what it's supposed to look like, then you need to ask for help, okay? Because at this point I'm expecting everyone to know how to do it. And it's okay if you don't, but you got to tell us. Okay, you got to say, hey, this doesn't make sense. I'm doing this wrong. Can I please have some help? Okay, so let's look at ordered pair or point A and find the ordered pair for A. Okay, so A, I'm going to look and see where does this line touch the x-axis. Okay, now look right here. That's the origin where I put that dot. This is my x-axis. This is my y-axis. Okay, so in this one, it's not labeled. Remember, I'm going to count how many jumps does it take to get here from the origin. So if I start at the origin, I'm going to jump 1, 2, 3 left. So my first coordinate is -3. Left means negative, and I went from 0 to 3 left. Okay, now let's do our y. So I'm going to start at point A and see where does it touch on the y-axis. Start at the origin. Okay, origin right there. I'm going to up 1, 2, 3, 4. I went up 4. Okay, so we just plotted our first point, or we just found the coordinates for point A. Notice the letter A is capitalized. It's capitalized because it's a specific point in this coordinate plane. It's capitalized because it names something specific. So no lowercase this time, because that letter A is not a variable. That letter A stands for the ordered pair -3, 4. All right, did you put parentheses around your two numbers? Okay, if you don't, you get points off. All right, now let's write the quadrant. So I'm going to number my quadrants again. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So what quadrant is point A lying in? Quadrant 2. Okay. All right, let's find point B. Point B, scanning for point, okay, here's point B, y'all see it? So I'm going to trace up and see what number, where does point B touch the x-axis? So start at the origin, jump 1, 2. Now I'm going to see, okay, where on the y-axis is it touching? Down 1, 2, 3, -3. So this is what you should be able to do to check your answer. I'm going to start at the origin and go right 2, down 3. 1, 2, down 2, 3, and you should end up back where you started, at point B. All right, what quadrant is point B in? 4. Do you have to use Roman numerals? The answer is yes. All right, look at C. C is a little tricky. C is right here. Where does it touch on the x-axis? So I know I'm starting at 0. And then how many did it go up or down? 2. Okay, but this is the tricky part. What quadrant is it in? Okay, it's on the y-axis. So point C is not in quadrant 2. It's not in quadrant 1. You can't say it's in between quadrant 1 and 2. It is in the y-axis. It's on the y-axis. All right, point D. Find the coordinates for point D. So take a second, find the ordered pair for point D. D is right over here. What is the GPS coordinates for point D? All right, Grayson, how many did you go right?
7.
Okay, right means positive, 7. Okay, then what did you have to do? Carissa, I went right 7, then what did I have to do? Say what? So here I am right here, and I have to get there. Would I go up or down? Up 1. So up means positive 1. All right, what quadrant is point D in? Quadrant 1. Oh, wait, wrong color. Quadrant 1. All right, E. Let's do the GPS. E. Okay, I started the origin. 1, 2, 3, 4. Left from the origin. AG, what'd you get? If I go left 4. So I'm on point E. Okay, it touches right there, the invisible line. It's on this line of longitude. If I start there and I go left 2, 3, 4, what number is that? Huh? Okay, and what does left mean? Positive or negative? Left means negative. So left, see I wrote negative, 4. All right, now I'm going to see where it touches on the y-axis. Or how many did I go down from the origin? What does down mean, people?
Negative.
Okay, so I know I'm going to start at the origin. I'm going to go down 1, 2, 3, 4, 5, 6. That's where E is, down 6. Okay, now let me double check. So I'm going to start at the origin, and I'm going to turn left 4, 1, 2, 3, 4, and then go down 6. 1, 2, 3, 4, 5, 6. And right where that dot is where E is. What quadrant is that?
3.
Quadrant 3. All right, now let's do ordered pair F. F. So everyone find F. It's right there. Okay, and if I start at 0 and drive my car to point F, how far do I have to go? Well, first, which direction am I going? Left. So, all right, I know it's going to be negative. Left means negative. Okay, and now let's jump. So I'm standing there. Jump there is 1. Jump there is 2. Jump 3. Jump 4. Jump 5. So I know I've got negative 5. Okay, now to get to point F, how many will I go up or down?
0.
None. 0. All right, and what quadrant is point F in?
Okay.
Is it in a quadrant? Nope. It's in between 2 and 3, but that's not a choice. It's on the x-axis. It's on the x-axis. Okay, so everything that we just did is a quick review, okay? What's new is these two terms right here. So the first word that we're going to talk about is discrete graph. A discrete graph is a graph with exact points. Okay, and here's Ms. Rush's definition. You can count them. You can count the points. So on this graph up here, could I count all the black dots? Look, there's 1, 2, 3, 4, 5, 6. There are exactly 6 points, 6 coordinates on this graph. Could I count them? Yeah, I can count them. Can you see every single point? Yep, 1, 2, 3, 4, 5, 6. I can see them, I can count them. I know exactly how many points there are on that graph. So a discrete graph is a graph with an exact number of points. Let's draw a picture. So I drew my X number line, that horizontal line. I drew my Y number line. And then what makes it a graph is me just putting some dots on there. So can you see the dots? Yep. Can you count them? Yep. I'm going to put another one. I'm going to make 7. Yep. Has an exact number of points. I can count them. I know how many there are. I can see every one of them, however you want to put it. That's a discrete graph. Now, the hardest type of graph to describe is a continuous graph. Okay? We're going to draw the picture first. So this is what a continuous graph looks like. Okay, it can look like one of my favorite things. A roller coaster. And if you look at this picture of this curvy thing, this roller coaster looking thing, if I said, Grayson, how many ordered pairs do you see in this graph? Do you know what he would tell me? He can't count them. Why not? There's an infinite number of ordered pairs there. Okay? Because everywhere that you see, look, ordered pair, ordered pair, ordered pair, ordered pair, there's an infinite number. And by the way, there's an infinite number in between the dots that I just put on there. Okay? Now here's another thing that's really, really important. See this arrow? That arrow means that this graph is going on and on and on and on forever and ever and ever to infinity and beyond. Okay? Now, anybody know which direction this arrow is going?
Up.
Up. Okay? Now, think about it. Up. Is up positive or negative? Up is positive. Okay? What about over here? What's it doing? Going down. Is down, think about y's, down is our y. Is that positive or negative? Negative. But hold up. Believe it or not, if I were to continue going this direction, watch my hand. This is what happens. The graph gets slightly righter and lefter, wider, 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 wider. So not only is this graph going up to infinity, it's also going left to infinity. Okay, and that's the confusing part. But you just got to remember that as this piece goes up, it's getting wider and wider and wider and wider to infinity. So it's getting lefter, and that's not a word, but it's going left and left and left as well. So as this guy is going down, it's getting wider to the which direction? To the right, to the right. So it's getting wider and wider and wider, righter, okay, going to the right. So that's the confusing part. So what we're going to do on Monday is we're going to talk about the domain. What's the domain? Who remembers?
Oh, the range of coordinates.
Well, the domain's opposite is the range. And domain and range are the coordinates. But remember, the domain is the x coordinate and the range is the y coordinate. So we're going to look at what's the domain and range of this and this. All right, now I want you to draw one more picture because this is also a continuous graph. Okay, so I'm drawing another picture of a continuous graph. Okay, and look at this picture. I bet you've seen this before. Well, that's, I mean, yes, this has slope, but what is this called? It's that thing that's straight. It's a line. Okay, so in Algebra Man, we talk about lines every day, like starting Monday, line, 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 every day. Okay, that's what algebra is. A line and what's it doing on the graph. And you guys just let us know, hey, we're going to be looking at slope and we're going to be looking at the y-intercept and which direction is it going and all these things. What's the domain? What's the range? So now we're getting to the real algebra part. Okay, now that we know how to solve equations, how do we solve literal equations, we can apply it to all of this that we're going to be talking about starting next week. All right, so a continuous graph, let's write a definition. Okay, so a continuous graph, what could we say? What do you think?
Graph that keeps on.
A graph that continues. It's connected. It can be a line or a curve. Okay, so it can be a line or a curve as well. It can be a line or a curve.